concept, and we will add an aggregate base class for our shopping cart model that we made in the last video. For some background, aggregate is a domain-driven design concept. It's a consistency boundary, meaning that it validates rules and it makes an object consistent. So if we look here at the shopping cart, that would be the aggregate and the way we set it up last video. So the shopping cart would have shopping cart items, and those items would be entities, and the shopping cart would own the items, and you would only be able to add items to the cart by first loading the shopping cart and then by calling a method on the shopping cart to add items. You can never just take an item and just store it in the database directly, because then you would bypass the rules that the aggregate has. So the aggregate maybe has rules like you can't add items to a checked out cart, or you can't add more than a certain number of items. I don't know, whichever rules you have in an aggregate, and that's the value of the aggregate. It makes the object consistent. And then we have value objects and entities are things within the aggregate. So in our example, the shopping cart, it will be the shopping cart item, and the shopping cart item has a price, and the price will be a value object. In this case, it has amount, so the amount, the cost, the price of it, and the currency. So maybe the currency would be USD or Euro, yeah, or whatever currency it is. And the value objects are compared by value, that's the name. So if you have a price, if you have two objects with the same amount and the same currency, if you compare them, they will be the same objects. But an entity is unique by its ID. So if you have two items with all the same properties except for the ID, they will not be the same. For example, maybe if you would model a user, you would have, there might be a user with the same first name, last name, even address, but they might have different IDs, and that's what makes them unique. Also, value objects are immutable, so once you have created them, you can't change anything on them. You have to create a new object with the new values to modify them. Yeah, so here we have a repository loading a shopping cart. This is how you would do it. You would load the shopping cart, and the shopping cart would contain the items. If you would do something like this, loading an item directly from a shopping cart item repository, you would bypass the rules of the shopping cart. But here it also depends on how you design your models. It's one of the hardest things, deciding on how big your aggregate should be, how many things it should contain, if if the items should be its own aggregate that you save, or if it should be contained within the cart. In this simple example with a shopping cart, it seems pretty reasonable to me that the item should be owned by the shopping cart, that you can't just add an item to the database without going through the cart. But there might be other domains where it's kind of harder to decide these things. For example, maybe you need to model a schedule for a doctor, and a lot of patients can sign up for time slots in this schedule. If you say you have the schedule for a week, and you have a model for the schedule, and it lives for a week of the doctor's time. So when you load the schedule, you can book a time slot within that week. The thing is, if you have a schedule like that, and there's a lot of users trying to book time slots during the same time, because it's the same model they're loading in, there might be concurrency problems when they try to save it, because someone else is trying to modify that aggregate at the same time. So that's something you have to consider when designing your aggregates. Uh, okay, let's move to some code. Okay, let's look at some code. We can see here that the shopping cart is now inheriting from the aggregate base class, and the aggregate has some constraints. It needs a type of ID and a type of state. And if we first look at the ID here, you can see that it's inheriting from the stream ID. So the aggregate needs it to be a stream ID. And the stream ID is just something to indicate that it's the ID for a stream, and a stream is because all the events in your aggregate will be stored in a stream in the database. So it will be a stream of events, and that's just to indicate that it's the ID for a stream. The stream ID is always a string because most databases where you would store your events uses a string as an ID. And the reason for having a specific type for each aggregate ID is because different aggregates have different logic for creating their ID. So you want to encapsulate that. Now for the shopping cart, it's really easy. It's just a random GUID for generating the ID. But you might have if you have a user aggregate, you might have a social security number, or if you have an application that's multi-tenancy where you can log in and see different parts depending on which tenant you're logging into. Maybe you will have your tenant ID in your ID of your aggregate. So that's why. And the aggregate state, that's just like the state you need to make your decisions in your aggregate. So for the shopping cart here, we just have like a checked out date and the shopping cart items, because that's what you need for the shopping cart. You need to check that it's not checked out when you add an item. You need to add items to the aggregate so you can remove them, and you can keep track of which items that have been added to the shopping cart. This state should be immutable, so you can't change this. You can only replace it, and the reason for that is that it makes it easier because you can know that you can't by accident change one property here. You can only replace the whole aggregate, and the only way to do this right now as it's set up is through these methods here. So the aggregate class has a abstract class that you need to implement that's called register state modification, and this is instead of the switch that we used before to check when different events appear. You want to change the state. So for example here, when the shopping cart is created, we add the shopping cart created event, and here we have added a method. We call this method when, that's in the aggregate base class, that says when the shopping cart created event appears, we want to set the ID of the state. So we take the current state, because this method it gives you the current state, so the states that the shopping cart has right now, and you get the event, and you need to return a new state, because as I said before, the state is immutable. You can't change anything on it the way I've set it up. You need to do it yourself, but I've used immutable array here instead of an array, so you can't change it, and I've tried to make as much as possible immutable. And it's only when you're calling these methods that the state is changed. So here we're returning the current state with the ID of it, the stream ID, and we're taking the ID from the event to set the stream ID. So after the shopping cart created event has been added, this method will be called, and the stream ID will be set in the state. And here we can see similar things for when adding items. We're adding items to the state, or we're returning a new state with the new item, or increasing the quantity. So I think this is a bit cleaner than having a switch. As you can just see here, it's pretty simple. When this event happens, the state should be modified this way. Um, Otherwise, the shopping cart looks pretty much the same. Um, there's one constraint: you have to have an empty constructor, and that's just because when you load events from storage, you need to apply them to your aggregate, and you can't do that without creating a new instance of the aggregate. So if we look at the test here, so this is when loading events from storage, you create a new shopping cart, and then there's a method in the base class that takes an array of events and it just applies them. Yes, if we look at this base class, it's pretty simple. It's just the things that we had before moved into this base class. So we have all the events, we have the uncommitted events. Here's the state modification method that we looked at with all the when methods. It gets called in the constructor, so whenever you create a new object, it registers all the state modifications, and here is the methods that is called for registering all of the state modifications. The load, when you load the event store, you load events from storage, and the add event, and this is used whenever you want to add an event from the application. So when someone has added an item to the shopping cart, for example, down here, we call the add event, and that will add the events to all events and uncommitted events. Okay, if you want to look at the aggregate state modifier, the only purpose of this class is modifying the state, and it's really simple. It's just a dictionary with the event name and an action of what to do when that event appears. So when you call this when method in the shopping cart here, it will call the when method here with that action that you have defined. So shopping cart we have here, we have an action or func. So when current you create a new current state and you set the stream ID of that new current state and return that. So that will get passed down here and will be added to the dictionary. Then when the actual event appear, it will just get the type from the event, which is the key in the dictionary, and it will try to get the handler, and it will call that with the event and the current state, and it will return the modified state. I have some logic here for just checking when it's the first event, because the first event always needs to set the stream ID of the state, because otherwise you can't save the aggregate. So it will throw an exception if you don't set the stream ID in your first event, because there's no way to store the events otherwise, because yeah, you need to have an ID for stream of events. So that's a pretty simple way of modifying the state. So if we look at the value object that I've added before, the price of a shopping cart item was just a decimal for the amount, but I've created a value object called price that has amount and currency, because you might want to know what currency the price is in. And also I've added some logic for when you create a price, so you can't create an invalid price, because price should never be below 0 or 0. You shouldn't be able to add a free item. Well, maybe you could in some web shops, but yeah, not in this example. So this takes care of the logic for creating a price, so you can't create an invalid price. And I've separated the behavior from the state of the price. So I have a simple class here called price state that has the currency and the amount. And this is just a stupid class. And then I have this price class for instantiating the state so that the state is correct. This makes it so I can get the state of the price, and I can store this class in events, because you should always store simple dumb classes in events, because you need to serialize them and serialize them to JSON. And if you have stuff like this with constructors and logics, it might be hard. I know that some serializers don't handle constructors that well, so that's something to think about. But yeah, I hope this was helpful, and if you wanna look at the code, it's in the description. Yeah, see you next video.